Hi everyone, can you all hear me? Sorry, I'm a couple of minutes late. I was having some issues starting the session. Let's see if we have any learners today, and then we will start the session in a minute, okay? All right, let me start today's session. So we're going to do squaring today, okay? The idea of this session is to help you simplify squares. And before that, let me just quickly introduce a couple of slides which are part of Creative Corner. And then for some of you who are new, so I think some of you may be aware of Creative Corner, but just quick introduction to those who are new to this. But Creative Corner is an initiative from Unacademy, offering unlimited possibilities of learning multidisciplinary skills. Whether in terms of creating a robot, playing chess, magic, to public speaking, of course, to Vedic Maths. A lot of additional skills that help you enhance your knowledge and also help you get into different fields, because having just linear knowledge on subjects is not enough. Also understanding from different dimensions, and also you have something to learn in new skills. It helps you get valued in the society as well, right? So Creative Corner is a great platform for that, and you should make use of it. There's some subscription for it, but let me tell you, every bit of money that you spend on Creative Corner should be worth it, because at the end of it you gain skills, and when you gain skills you can teach others as well. So that's something very valuable. As I said, lot more happening on Creative Academy, Creative Corner since it started. There's a lot more coming also into Creative Corner. This is the list of topics. Okay, so of course, you have the benefit of learning from the comfort of your home, unlimited access to a lot of courses, and the best part is access to a lot of educators on one single platform, right? So that's something really good to look forward for. And do check out Unacademy Ascent. The links are in the description below on this channel. And there's an event happening on 13th Feb, 11 a.m. to 12 p.m. A lot of prizes to be won, up to 5 lakhs of scholarship. Exciting. So quick introduction about myself. I'm going to quickly zip through it because some of you have probably seen my videos before, so I don't want to keep talking about myself. Vedic Maths as well, introduction about Swamiji, and his knowledge that he's documented over so many years, that is being proven to be useful and helping make mathematics easy and fun. So let me quickly get into, we covered a couple of topics in the, first two sessions around general multiplication. We covered some base multiplication, and we will talk about squaring today. And before we go into squaring, we're going to, quickly understand one concept here that is called the duplex. Okay, and duplex is something that, for now, understand that it is going to help you create or help you solve a squaring problem. Okay, an individual unit of duplex, when you combine it, you will be able to get the result of a square. So but very simple. When I ask you, what is the duplex of a single digit, the duplex of a single digit is the square of itself. That's all, nothing else. The duplex of 4 is 4 squared. That's it, right? Duplex of a 2-digit number, 4 and 3, is double the digits, 2 into 4 into 3, which is 24, right? The duplex of 1, 2, 3, when you have a 3-digit number, what do you do for a duplex? 2, you multiply the outer pair, 2 into 1 into 3, plus square of the inner pair, right? And when you have a 4-digit number, you multiply the outer pair and add it to the inner pair, multiply the inner pair as well, right? So as long as you know how to find out the duplex of a single number, duplex of a double number, 3 numbers and 4 digits, you are able to actually solve a lot of squaring problems. Okay, so keep this table in mind. You can take a snapshot, quite useful, and we will talk about the application of it in the coming slides. Okay, so essentially, right, how do you use the duplex to find a square? Okay, suppose you're trying to find out the duplex of 12, suppose you're trying to find out the square of 12, right? 12 squared. So the very first step is, now watch out for these colors, okay, because I put the colors for a reason. The orange colors mean you're finding the duplex of a single digit, okay, and the result of that is what is here in that orange. Okay, so you know that the duplex of 1 is a single digit. What did I say? The duplex of a single number is a square of itself. So 1 squared is 4. The duplex of 1, 2, right? So first you find, then you find the duplex of 2. So that's how it follows in sequence. First digit, the sum of all that effectively is the answer. So duplex of 1 and 2 is the double of those. Remember in this table that we saw, right? What did we see in this table? So Menti is here. Okay, I was just seeing somebody joined, so I was, so hi. Okay, all right. I quite didn't understand that your statement there. Okay, so let's look at the duplex of 1 and 2, right? What's the duplex of 1 and 2? Here 12 is twice the product, 24, right? So that's how you write it here. The duplex of 1 and 2, sorry, 1 and 2 is not 24. 1 and 2 is 2 into 1 into 2. What is that? 4, right? And finally, the duplex of 2 is a 4. So that's how you get this answer, 144, right? 12 squared is obviously 144. Now, this may sound very, you might be wondering, I know 12 squared table, I can really find out. But see, the idea is you need to know how you derive it for small numbers, and then you gradually expand to bigger numbers. So now when you're trying to find out the duplex of 1, 2 and 3, when you're trying to find out the square of 123 squared, it's slightly bigger, right? You need to do it step by step. Now also, if you remember, I don't know if you've attended the last session on base multiplication, there is also a way to solve 123 into 123 using base multiplication method as well. Okay, but right now we'll stick to finding the squares using duplex. I believe finding squares using duplex is a lot easier than any other methods. With practice, this becomes faster actually. Okay, so of course your choice in what method you want to do, but over the period of these courses I'll be exposing you to different methods to help you solve squares in any which way you want. Okay, and you can choose our brains work in different ways, right? Sometimes we are faster in certain steps, sometimes we do faster in another other sequence when you're given. So choose your own method. So now let's try to find out the square of 123. So the very first step is to find out the duplex of 1 and 2. Oh, sorry, 1, right? What's the duplex of 1? Which is a 1, right? 1 squared is 1. Duplex of 1 and 2, right? The next step is to find out, look at the highlight that I'm doing, to find out the duplex of 1 and 2. What is the duplex of 1 and 2 is, right? Duplex of 1 and 2 is twice of 1 into 2, right? Now you find out, you find out the duplex of 1, 2, 3, all the three numbers together. What's the duplex of 1, 2 and 3? Multiply the outer pair, double the outer pair, 2 into 1 into 3, right? What is 2 into 1 into 3? 6, right? Plus square of the middle pair. Remember this this table that I have. 2 into 1 into 3 plus square of the middle pair, right? When you do that, what do you get? 2 into 1 into 3 is 6 plus 4 is 10, right? So I will write 10 this way. See, why am I writing 10 this way? Is these all come with a carry. Okay, you're allowed only one digit, right? It's your allowed only one digit. This goes on to the higher power, the next power. Okay, so that's why this will come as a carry. Now hold on to the carry there. Only one digit you write, and the remaining whatever the digits you get, you put it as part of carry, right? So you write it as 10 this way, right? Now let's look at the duplex of 23. After that, you find the duplex of 23, these two digits together, right? What's the duplex of 23? 2 into 2 into 3. What is 2 into 2 into 3? 12, right? 2 into 2 into 3 is 12. So I will write 12 like this. Look at the color code that I've given, right? The color code is meant to you to correlate that this duplex ka answer is this, right? So 12. And then finally, easy peasy, you have to find out the duplex of 3. What is the duplex of 3? Duplex of 3 is 9. So now when I write this answer like this, 1 4 1 0 1 2 1 9, this 1 has to carry forward here, right? When this 1 gets added over to 4, what it will become? 5, right? And this 1 also will get carried over here. This 1 plus 0 is a 1. So that's how your answer is 15129, right? You're going to get the, see, I would have explained it in like 3-4 steps, but this you will do it instantly on a pen and on a paper, or with a paper and pen. When you write it, you will be doing it more faster, right? First you'll find out the duplex of 1, then you'll find out the duplex of 1 and 2, then 1 2 3 2 3 and 4. Now with the 4-digit number, obviously it's going to be a little longer step, okay? But see, all this now, the answer, the reason why we are doing all this is okay, I had an algebraic explanation to this, but effectively, right, if I write, let me write this here, this example itself, right? If I take this example, if I write this as 10 plus 2 square, some of you will be familiar with a plus b squared ka formula, no? Actually, I'm actually doing the same thing only. This it's a plus b squared only, right? So when I write it in this form, if I write 12, I can write 12 as 10 plus 2, no? So when I write it in this form, a plus b squared form, what do I get? What is the expansion of a plus b squared? A squared plus 2ab plus b squared. This is a squared, this is 2ab, and this is b squared. That's all you're doing. And when it comes to a larger number like this, right, you can do it in two ways also, right? You can write this as, right, if you want to write it as a longer number, you would write it as 100 plus 20 plus 3. So what is this formula? This will be an a plus b plus c squared ka formula, right? And for that also you have, we all, if you're really get in deep into algebra now, you would know that also. And this is what you will get. This is ultimately what the duplex that that you're calculating you will get. Okay, but the easiest way in Vedic maths is trying to simplify things one digit at a time, right? So you don't need to know any algebraic formula and all that. You're only finding out the duplex of 1, then the duplex of these two numbers, then the duplex of all three numbers, and then go it, shift, going from this side 2 3 and 3, right? So 1 1 2 1 2 3 2 3 and 3. Similarly, when you come to a 4-digit number, first you find the duplex of 1, then 1 2, then 1 2 3, then 1 2 3 4, and then you find out 2 3 4. You go backwards like this: 2 3 4 3 4 and 4. So you're able to actually solve much bigger problems as well, right? Did this come down here? Oh, this square is supposed to be here, no? How did that guy walk up there? Okay, see, you're able to get even a four digit number ka square. You're able to get it very instantly. So again, to recap, here I would find out the duplex of 1, which is a 1. Duplex of 1 and 2 is a 4. Duplex of 1 2 3 is a duplex of 1 2 and 3, right? Yeah, so I have it, maybe I have the color. Oh yeah, I have the color right only. Duplex of 1 2 and 3 is a 10, right? Then duplex of 1 2 3 4. Remember in this table, what is a duplex of a 4-digit number? Twice the outer pair plus twice the inner pair. Twice the outer pair plus twice the inner pair, right? Easy, no? So twice the outer pair is what? 2 into 1 into 4. Quickly calculate in your mind. 2 into 1 into 4, right, is twice the outer pair, right? So which is effectively 8. And what's the inner pair? Twice of the inner pair is 2 into 3 is 6. 6 ka double 12. So 12 plus 2, 12 plus 8, na? You calculate 12 plus 8, na? That is 20, right? Now you find out the duplex of 2 3 4. Now it's the same thing, same pattern. 3-digit number ka duplex is twice the outer pair plus square of the middle number. So twice the outer pair is 2 into 4 is 8. 8 ka double 16 plus 3 squared 9 25, right? And then the duplex of 3 and 4. Duplex of 3 and 4, you know, it's easy, no? What is the duplex of 3 and 4? Twice 2 times 3 into 4. So 3 into 4 is 12. 2 times of 3 into 4 is 24. And then finally easy peasy duplex of 4, which is 16. Now you write that answer like this in one line like this, and then handle the carries, manage the carries, and you get your answer. So if you are going to do 1 2 3 4 into 1 2 3 4 by your traditional way, you are going to take longer time. Your time to do this will be at least 5 to 10 times faster than, and Vedic maths most of the problem solving is between 5 to 10 times faster than your traditional way. Okay, so I hope you got a gist of it, and I don't know if somebody is on this. So I wanted you to take a shot at first finding we'll find out the duplex of each of these numbers. This is just not finding a square. We are just finding the duplex, okay? Because finding the duplex, if you know the duplex, then finding the square is just combining all those duplexes, right? So Soumya, if you're there on the Soumya Ranjan Das, I don't know if anybody else is there. I see others. But can you tell me the duplex of 5? Can you put it on the chat? So we'll solve it, okay? So we'll solve it one by one. So the duplex of a single digit number is the square of itself, which is 25. So let me write it this way. Duplex of 5 is 25. Now what's the duplex of 2 and 3? Is 2 twice of the product of the digits, right? So product of digit is 6. Twice of the product is 12. Duplex of 55 is, what is 5 into 5? 25. double of 25 is 50. Duplex of a single number is 9, right? The duplex of 1 2 3 is twice the outer pair. So 2 into 1 into 3. So 3, double of 3 is 6 plus square of the middle number. So 10, right? I think we saw it in the earlier example here. D of 1 0 1. Here twice the product of the outer pair. 1 into 1 ka 1. 1 into 1 is 1. 1 ka double is 2 plus 0 squared, which is, that's all, right? So these are the duplexes. So this is the, how do you find out duplexes? Practice. I have put a few more examples here so that you get a handle of it. And let's look at these examples. So more examples will help you reinforce the concept, right? So here you go. The square of 43. So what did I say? First you find out the duplex of 4, then you find out the duplex of 4 and 3, the duplex of 3, and combine them together. So the duplex of 4 is 4 squared, duplex of 4 and 3 is 2 into 4 into 3, and duplex of 3 is 3 squared. Now you bring that down, 16, 24 and 3 squared. Now remember what I told you about that carry. There's only one digit allowed, so this 2 will have to go here and this answer will become 1849. So I hope it's clear, right? One more example just to reinforce that, okay, is once you do more examples, then the concept is reinforced. And when you deal with smaller numbers initially, you are able to handle larger numbers more effectively, right? So 64 ka squared. So first you find out the duplex of 6, then you find out the duplex of 6 and 4 and the duplex of 4, right? So duplex of 6 is 6 squared, 66 4 is 2 into 6 into 4, duplex of 4 is 4 squared. See, the outside pairs are very easy to calculate, na? The outside pairs, all you have to do is a square of it. The inside, when it comes, you have to do twice of the product usually, right? When you have a 3-digit, you have to also do twice the product plus adding the square. But if it's a 2-digit number, it's very easy. You just find out first. The simple way to do it is multiply those two numbers and then you double it, okay? Always it is easy to find the double of a number than multiplying it. You can do it, you can do it 2 into 6, 12 into 4. Instead of that, it is easy just to multiply it and then double it, okay? Don't do at 2 into 6, 12, 12 into 4, you're trying to find out 48, na? It's easier to double it, okay? So forget about the doubling first, multiply the number, then double it. So here you get 36, this becomes 48, and this becomes 16. Now remember about, you're allowed only one digit in the actual number, because see, these are all based on the place value system, right? So units, tens, hundreds. So ultimately that's what this is. You're getting the units place, tens place, hundreds and thousands. So this is basically part of, not part of this place value system. It will be, it will have to be borrowed over here. The carry will come here. So when 36 gets carried over here, it will become 40, right? And then when this 1 gets carried over here to 8, it will become 9. So that's how the answer is 4096, right? So now here there's a little bit of a tip for you, okay? I told you about, earlier 1 2 3 squared, you can do it as a plus b plus c squared also. You can also write it in a fashion of, a plus b squared if I consider 12 as one of my number and 3 as my second number. So if I consider 12 as my one number and 3 as my other number, then what do? I find out the duplex of 12, right? 12 ka duplex is 144. Since it's a small, anything that's part of your multiplication table, where you're kind of by hearted your squares, try to utilize that, right? Try to utilize that. So duplex of 12 is 144. Duplex of 1 2 3 is, again, as I said, multiply 12 into 3, you get 36. 36 ka double is 72, right? And then duplex of 3 is 9, right? So you write down like this: 144, 72 and 9. This 7 gets borrowed over here, right? This, consider this as one full number. So you add 144 plus 7. What do you get? 151, right? 29, 151, 29. So that's how you get the squares of numbers. Okay. Even larger 4-digit, 5-digit also you can do. Now if you see now, if you want to do 5-digit, I can, you know, uh, tell you, if you add another number here as a 5-digit number, you will follow the same pattern, right? But you will be adding more duplexes to it. That's it, right? When you find out 1 2 3 4 5 ka square, so first you will find out the duplex of 1, then the duplex of 1 2, 1 2 3, 1 2 3 4, right? And then the duplex of 1 2 3 4 5, right? And then you work backwards. Then the duplex of 2 3 4 5, 3 4 5, 4 5, and then 5, right? So it comes with practice. You might think, you know what, there's more number of steps, but you can prove it yourself. Try to do 1 2 3 4 5 in a traditional way and try to do it in the Vedic Maths way. You will be able to get the results faster, but initially probably time might be the same because you're getting used to the method. But over a period of time, you will find that this method is much simpler and much easier, and you will get more accurate results. That's the best part of it. Okay, when you're doing traditional way multiplication, you're handling and you have to do so much of addition at the end, you can make mistakes. In this, the chances of mistakes are less because you have less number of steps. When you have less number of steps, obviously the chance of mistakes are less, right? It works that way. The less number of steps, less chance of mistakes, and you're dealing with small numbers at a time. Okay, so this was quick insight on on squaring, right? And this is what I wanted to do a poll, but I don't have a lot of students. Maybe most of you are at school by now, and you may be seeing this, a recorded session. But I have a few questions for you. Just glance through this, take note of it, and try to find out the answers for this. 85 squared, 102 squared. Of course, you can take your own questions, your own choices. If you have the method, you can solve any problem. You don't need any specific questions also, right? But recording and then see, at least I have put some options there, and you can quickly validate your answer. Of course, you have your calculator as well to validate. Okay. So trust me, with practice, you get perfection, and you are going to explain this to others as well. The best part about learning anything, any subject, and with Vedic Maths, it is all the more interesting because there is a wow factor, right? Oh, how did I get this so fast? This is a method, and and everybody loves to do things fast, and especially with mathematics, if you're able to get a handle of numbers, it is going to help you in your life now, in future, for a long time to come, right? We are all going to be dealing with numbers for a very long time, right? Even if you're not in the field of mathematics, you in your life now, in future, for a long time to come, right? We are all going to be dealing with numbers for a very long time, right? Even if you're not in the field of mathematics, even to manage your own finances, even at work as well, right? Today I also work, right? I mean, I work in the IT industry, and I have to deal with a lot of numbers, so it helps me if I'm able to quickly get a handle of numbers. And in work life, you might not be using algebra or trigonometry and calculus and all that unless you are in that specific deep science field, or but in a traditional normal corporate job, if you're going to get in, or if you're going to do your own business, you need to have a good handle of numbers. And so that's why I found this topic very interesting on Vedic Maths, because of course I didn't go into a lot of history on Vedic Maths. We usually do in a lot of sessions. I want to focus on the content, but you can look it up, Google it. Very interesting. Vedic Maths is something that a lot of our students have not discovered. Okay, so with that, I would like to thank you for joining me today. I'm hoping that you will be reviewing this recorded session. Please do put your comments in, and then I'll be happy to answer them. If I get to read those comments, I'll be very happy to answer them on the chat window of this YouTube link. Okay, so till then, goodbye, and I'm signing off. You take care. Bye bye.